gama pa ma pa ma pa da pa ma da pa ma ga ri ga ri sa.
Good morning, children. Today we will see how to find the area of the segment of the circle. Okay, we have already learned how to find the area of sector of the circle, but in this session we are going to see how to find the area of major segment of the circle and the minor segment of the circle. Very interesting. Let us see how the area of the segment of the circle is calculated. Okay, we have already learned about the segment of the circle. Okay, look at the figure here. This is a circle with center O, and here I have drawn a chord AB. This chord AB divides the circle into two parts. Okay, here this AB is called the minor arc. Therefore, the chord and this minor arc cover some place. The place covered by this chord AB and the minor arc AB, okay, is called minor segment. Okay, then this is the major arc and this is the chord. Therefore, the place covered by this chord and this major arc makes a major segment. Okay, thus when the chord AB is drawn, the circle is divided into two parts like this. Okay, this chord and this major arc make the major segment, and this chord and the minor arc makes the minor segment. But today in this session we will learn about if the question is asked to find the area of the minor segment, how the area of the minor segment is calculated and how the area of the major segment is calculated. Okay, look at me, children. Here area of minor segment is asked. The formula is area of minor sector minus area of triangle OAB. See here, this is minor sector, right? Here OBA is a minor sector and this is AB. AB is a chord, and this arc is minor arc. Therefore, this is minor segment. See here, OBA is minor sector, and in this minor sector we have a minor segment. Okay, this chord AB and this arc AB makes minor segment. Okay, if anybody asks us to find the area of this minor segment, what will we do? Area of this minor segment is calculated as, first you find out the area of this sector. Okay, in the area of sector OBA you subtract the area of this triangle, then you will get area of this minor segment. Did you understand? Here OBA is a minor sector. In this region is minor segment. If minor segment area is asked, there is no direct formula to calculate the area of minor segment. First you find out the area of the minor sector OBA. In this area you subtract the area of triangle, then you will get the area of this minor segment. Okay, so we have the formula here. Area of minor segment is equal to area of the minor sector minus area of triangle OAB. Okay, but children, the area of the segment depends upon the type of the triangle here. Okay, here area of minor sector depends upon the value of theta. Okay, but area of triangle depends upon the type of the triangle. Okay, if here the triangle involved in this sector is equilateral triangle, then what happens, this two radii and this chord all will be equal. Therefore, it is an equilateral triangle. That's why to find the area of this equilateral triangle, we use the formula root 3 by 4 a square. Okay. Here, if this triangle AOB is a right angled triangle, okay, a right angled triangle, then see, this is the sector and this is the segment. If we are to find out the area of this segment, what we should do is area of the sector minus area of this triangle. Okay, but here the triangle is right angled triangle. Therefore, the area of the triangle is half into base into height. Okay, here we should not take this as base because we don't know its length. But here OB and OA are the sides of the right angle triangle also, and base and height of the right angle triangle also. Therefore, if the right angle, here the triangle involved is right angle triangle, we take half into base into height. Here base is OB, which is radius, and height is OA, which is radius. Therefore, half into base into height becomes half into radius, it is half radius square. So area of the right angle triangle is half radius square in this sector, right? Okay. If the triangle involved in the sector is not an equilateral triangle or is not a right angle triangle, then the area of this triangle is calculated by taking the formula half into base into height. Okay, here I can take this BA as base and this line as height. Okay, I should draw perpendicular from O to this AB, and that becomes height. If we calculated the value of height and base, then the area of the triangle involved in this sector is calculated. Okay, now let us see one by one. Find the area of this segment if the sector angle is 60 degree and the radius is 7 centimeter. Okay, look at me here, children. Here OBA is sector and sector angle is 60 degree, and here AB is chord. Therefore, this chord and this arc make this segment. The shaded portion is segment. You have to find the area of this segment. So children, first find out the area of the sector OBA, okay, minus the area of this triangle AOB. Then you will get the area of this shaded portion, which is the area of minor segment. Okay, here in triangle AOB, OB and OA are radii of the same circle, and both are 7 centimeter, 7 centimeter. Okay, and we know that the sides opposite to equal angles are equal, and the angles opposite to equal sides are equal. Therefore, children, here see here, one angle is already 60 degree, and OA and OB are two equal sides. That's why AOB is an isosceles triangle now. Okay, then the angles opposite to equal sides should be equal. Okay, so here OA and OB are equal sides. Therefore, the angle opposite to OA and opposite to OB must be equal. Okay, see here, children, we know that OB is equal to OA and OA is equal to OB. Therefore, the angle opposite to OA, if it is X, then the angle opposite to OB should also be X. Okay, but if we add all these three angles, they should be 180 degree, and angle A and angle B should be equal to each other. Therefore, here what happens is this angle and this angle should be equal. Already this angle is 60, and the sum of these two angles should be 120, and this should be equal also. That is why this is also 60 and this is also 60. Therefore, this is equiangular triangle, and when all the three angles are equal, then all the three sides must be equal. That is why OA and OB and AB must be equal, because it is an equiangular triangle and therefore it is equilateral triangle also. Therefore, AO, OB and BA, all the three lengths are equal to radius of the sector or circle. So children, let us find if theta is equal to 60 degree, R is equal to 7 centimeter, that is equal to A. Here A is the length of each side of the equilateral triangle. Okay. So we have area of minor segment is equal to area of the sector minus area of this triangle, right? This triangle is equilateral triangle, therefore the equilateral triangle area is directly calculated by root 3 by 4 a square, right? And here area of the sector is for 360 degree phi r square is the area, and for theta how much is the area? Here theta is 60 degree, therefore phi r square by 360 into 60 minus root 3 by 4 7 square, right? Here 0 0 get cancelled, 6 1s are 6 6 are, therefore phi r square by 6 minus root 3 by 4, 7 square is 7 into 7. Here 7 7s are 49, therefore 49 root 3 by 4, and here phi is 22 by 7 into radius square is 7 square into 1 by 6 minus 49 by root 3 by 4. Okay. Then 22 by 7 into 7 into 1 by 6 minus 49 into root 3 by 4. So 7 1s are get cancelled. Therefore we have 11 7s are 77, and here 2 3s are 2 11s are. Okay. 7 1s are get cancelled. 2 3s are 2 11s are. Therefore it is 11 7s are 77 upon 3 minus 49 root 3 by 4. Okay. Now the LCM of 3 and 4 is 12. Okay. 3 4s are and 4 3s are. Therefore 4 77s are 308 and 49 3s are 147 root 3 by 12. Okay. As the LCM of 3 and 4 is 12. Now 77 4s are 308 minus 49 3s are 147, then into root 3 upon 12. Root 3 means it is 1.73, right? Therefore I will take it as 308 minus 147 into this root 3 is 1.73 upon 12. Therefore 147 into 1.73 is 254.31. Okay. So 308 minus 254.31 upon 12 is equal to 53.69 upon 12. That is 4.47 centimeter square is the area of the segment. Okay. Whose central angle is 60 degree and the radius is 7 centimeter. Is it clear? Okay. Now let us take one more example. If theta is 90 degree and radius is 7 centimeter, what is the area of the minor segment? Look at this figure. Here AOB angle is 90 degree, radius is 7 centimeter. Okay. And we need to find out the area of this segment. Okay. So area of this segment is equal to area of this sector with central angle 90 degree minus the area of this triangle. Okay. First find out the area of the sector. In this sector, if you subtract the area of triangle AOB, then this remains, which is the required segment. So children, area of the minor segment is equal to phi r square by 360 into theta minus half into base into height. That is area of the triangle. Here, this is right angle triangle. Therefore, I take this as base and this as height. Therefore, half into base into height. Here, half into base is also radius and height is also radius. Thus, half into r become half r square, means radius square. Okay. Here, phi r square by 360 and theta is 90 degree. Therefore, 91s are 94s are phi r square by 4 minus 1 by 2 r square. Here children, r square is common, therefore I take r square outside. Therefore 5 by 4 minus 1 by 2 remains inside. Okay. 5 means 22 by 7 into this 4 becomes into 1 by 4 minus 1 by 2, 7 square, right? So it becomes 11 by 4 minus 1 by 2 into 7 square. What is the LCM of 14 and 2? It's 14. Okay. Therefore, 14 ones are and 2 sevens are. Therefore, 1 11s are 11 and 7 ones are 7. 11 minus 7 is 4. Okay. So it is 4 by 14 into 7 square. This is 7 into 7. And here 2 2s are and 2 sevens are. Therefore, area is 2 upon 7 into 7 into 7. Okay. 7 ones are, 7 ones are, then 7 2s are 14. Thus, the area of the minor segment where the sector angle is 90 degree is 14 centimeter square. Okay. So children, if theta is 90 degree and radius is 7 centimeter, then the area of this minor segment is how much? 14 centimeter square. Means we can place 14 1 centimeter squares inside this, right, segment. One more very interesting example. In this sector, you will see that OAB is a sector with central angle 30 degree, right? And here AB is the chord and this shaded region is the segment. Find the area of this segment is the question. Okay. Here the central angle is 30 degree. So the area of the minor segment is equal to 5r square by 360 into theta minus area of this triangle AOB or OAB. If you take AB as base, then you have to take OD as height. Therefore, half into base into height. Here the triangle inward is not a right angled triangle, or the triangle inward is not an equilateral triangle. That is why we must have to use the formula half into base into height, and we should find the length of AB and we should find the length of OD. Okay, by any means. Now you see it is 5r square by 360 into theta. Therefore 5r square by 360, theta is 30 degree. So 0 0 get cancelled and 3 1s are 3 12s are. Thus 5r square by 12 is the area of the sector minus area of this triangle OAB. This is half into base into height. Base is AB, height is OD. Therefore AB into OD, right? When I measured, if suppose, okay, if this length AB is 4 centimeter and this length OD is 6 centimeter, means base is 4 centimeter and height is 6 centimeter, then we have half into base into height. That so 2 1s are 2 2s are get cancelled, 6 2s are 12. Thus it is 22 by 7 into 7 square is 7 into 7. 7 7 get cancelled and 22 7s are 154 minus 12 is equal to 142 centimeters square. Therefore, area of the minor segment whose central angle is 30 degree and radius is 7 centimeter is how much? 142 centimeter square. Okay, right. Let us take a very interesting thing. If we are asked to find the area of the major segment, what we will do? So far we learned how to find the area of the minor segment, and now we are going to see the area of the major segment. Okay, if theta is 90 degree, radius is 7 centimeter, find the area of the major segment. Okay, see here children, this is one full circle and here OB and OA are two radii, right? And this AB is major arc, right? So this chord AB and this major arc AB make major segment. I have to find out the area of this major segment. Okay, but see here children, in the entire circle, if you subtract the area of this minor segment, then you will get the area of the major segment. So I write area of major segment is equal to First you find out the area of circle. Find out the area of full circle. So area of circle minus the area of minor segment. Okay. This AB chord and this AB arc makes the minor segment. Okay. In the entire circle, if you subtract the area of this minor segment, then you will get the area of major segment. So area of circle is 5r square, right? Minus area of minor segment. But just now we have learned how to find out the area of minor segment. Okay. Area of minor segment means it is area of minor sector. Okay. First you find out this area of minor sector minus the area of triangle, then you will get area of the minor segment. So area of minor sector minus area of triangle AOB. Here area of minor sector is 5r square by 360 into theta, and area of triangle AOB is half into base into height. So children, here this central angle is 90 degree and the radius is 7 centimeter, and I need to find out the area of this segment. So area of this segment is equal to 5r square by 360 into theta minus half into base into height. Here the triangle involved is right angle triangle. That's why half into base into height is half into radius into radius. Okay. I am not taking AB as base. I am taking OB as base and OA as radius. Therefore half into base into height. It is half r square. So 5r square by 360 into 90. Then its simplification, okay, goes up to, right, 14 centimeters square. Therefore, instead of this 5r square by 360 into theta minus half base into height, I can place 14 centimeters square. Therefore, this 5r square is 22 by 7 into 7 square. This is 22 by 7 into 7 minus 14. So 7 and 7 get cancelled here. 7 ones are 7 ones are. Therefore, 22 sevens are 154, and this is minus 14. Therefore, children, 154 minus 14 is equal to 140 centimeters square. Therefore, the area of this major segment is 140 centimeters square. Okay. So children, in this session, we learned how to find out the area of the major segment and how to find out the area of minor segment. Okay. I hope you have learned this session very well, and work out some more problems regarding this, and you will become perfect. Okay. Thank you so much. See you tomorrow. Goodbye.